The second law of thermodynamics tells us that the universe evolves towards disorder. But when we look around and at ourselves, we see all of this incredible structure. And so how can this be? Why are we not just disorder laying on the ground? Well, it takes work to maintain this order and structure. And so life is essentially a continuous battle against disorder. So what is doing this work? Well, within every one of our cells, there are millions of molecular machines working to maintain an environment that's very different from the cell's surroundings. Now, my favorite molecular machine is called ATP synthase. And in this cartoon structure, we can get an idea of what it does. So this orange crankshaft in the middle rotates, and this is coupled to chemical reactions happening on this outer barrel structure. And experimentalists have found that one rotation corresponds to exactly 3 chemical products, these green triangles, being produced. And the reason this motor is so important is that it turns out these green triangles are actually the fuel for all other molecular machines in biology. Now, as a theoretical physicist, I'm interested in the limitations of this machine. What are the trade-offs between the work it takes for me to turn this central crankshaft, how fast I'm trying to do that, and the accuracy of this system? Where by accuracy I mean, did I actually get 3 chemical products after one rotation? So by creating a computer simulation of this model, I can explore the fundamental physics of molecular machines. So what I have found is that as I try and go faster, the accuracy decreases from 100% to 0%. I've also found that at slower speeds, if I try and go faster, the work actually increases the faster we go, but eventually reaches this peak, after which it actually is less work to try and go faster and faster. But we notice that this peak corresponds to where accuracy is dropping off. And so we can see now that if you put in the same amount of work, you could either go faster with lower accuracy, or you could go slower with a higher accuracy. We can also consider this system in the space of accuracy and work, where an ideal motor would be in this upper left-hand corner with 100% accuracy and minimal work. And this line corresponds to a prediction from a very simplified physical system, and the dots correspond to my own simulations. The future of my research asks whether we could ever cross this line. Can we drive this system in a way that is actually doing better than this theoretically predicted limitation, perhaps in some intelligent way? So my research is really helping us understand the fundamental limits that life is facing in this continuous battle against disorder. Thank you.